Hi friends, last time we have seen the operation of mass spectrometer. By controlling the electric and magnetic fields, we can accumulate some particular mass of particles, and by finding the radius and the values of electric and magnetic fields, we can easily determine the mass of the elements. Similarly, if we set the mass spectrometer on a single mass and collect for a very long time, and we can fix the electric and magnetic field. Equation electric and magnetic field, we can control the R, and by controlling these values we can fix the mass, right? By fixing the mass and controlling, we can accumulate a large quantity of a particular isotope that is enough to use for a laboratory experiments. Some mass spectrometers are also designed to process large quantities of material. And we can also use this mass spectrometer. If we use it in a particular way, we can use it for isotope separation. One of the method is laser isotope separation. Laser isotope separation. This is the schematic diagram of laser isotope separation. This is also an important question that may also be asked in the final exam. So be careful and learn to draw these pictures, these images, and read these paragraphs. Okay. The laser isotope separation. The beam of this is oven, laser 1, laser 2, this is deflector, this is the collector. Okay, separate. The beam of neutral atoms from the oven is a mixture of 4 isotopes. This is a mixture of 4 isotopes, A1, A2, A3 and A4. Okay. The first laser is tuned to the transition corresponding to the resonant excitation of isotope A2. This laser excites the A2 only, okay, to a certain excited state. Because of the sharpness of the laser energy and isotope shift, that gives that particular transition a different energy in other isotopes. Only A2 is excited using the laser A1. The second laser has a broad energy profile so that many free electron states can be reached in the ionization of the atoms, but because only the A2 isotopes are in the excited state, only the A2 atoms are ionized. The A2 ions are deflected using the deflector and collected by the collector. So in simple words, we can say that a oven is a collection of isotopes. Laser A1 excites a particular isotope. Laser A2 ionizes the excited isotope, then it becomes charged. This deflector, by applying potentials, that can deflect the charged atoms or isotopes, and the uncharged isotopes are undeflected, and the deflected isotopes are collected by the collector. This is the method of isotope separation, laser isotope separation. Laser isotope separation. A completely different technique for separating isotopes takes advantage of the extremely sharp beams available from lasers. The optical radiations of different isotopes of the same element do not have exactly same energy. Their differences in nuclear size cause small variations in the transition energy called the isotope shift. A beam of neutral atoms passes through a laser beam, which is turned so that electrons in the desired isotope will absorb the radiation and make a transition to a particular excited state. Isotope shift. A second laser beam is set to a wavelength corresponds to ionization of the excited atoms. The final energy states of the free electrons are continuous rather than quantized, and hence the second laser should have a broad energy profile. This will not result in the ionization of the unwanted isotopes because only those that have been excited by the first laser have electrons in the excited state. After passing through the second laser, the beam consists of ionized atoms of one isotope and neutral atoms of all the others. The excited atoms can be removed from the beam by an electric field and collector. Okay. Then we will see the binding energy in the next.